Shooting it raw?
Yes, shooting it raw. So this one is called, I guess, 500 million years of CO2 and temperature. So it's a graph, another graph. On the left, you have parts per million of CO2, and on the x-axis, you have million years ago, thousands of years ago, and hundreds of years ago, and roughly plotting, I guess, parts per million of CO2. Okay.
Yeah, so
So
parts per
explain
million
this chart.
CO2 is that. Yeah, so you can see the parts per million CO2 is the dotted line,
Mm-hmm.
and temperature change, so above an average period between the year 1850 and 1900,
Mm-hmm.
is the solid line, and that's basically temperature. So all we're plotting here is temperature change versus parts per million, so that's concentration of CO2 in the atmosphere, and we're doing it back for 500 million years.
Right.
So again, what I found when coming to look at all of this stuff is that I could find a chart of CO2 measurements and temperature going back 70 years.
Right.
Or I could find different charts going back maybe 1,000 years. Or I could find, one going back maybe 100 million years, but then not giving the detail on the kind of later period.
Sure.
So what I wanted to do was just take in one image, just show the relationship between how much CO2 there is in the atmosphere, and CO2 is obviously a greenhouse gas, which scientists understand warms the planet, and what the temperature of Earth was at that point. So this chart very simply shows you that for 500 million years, temperature and CO2 have basically moved in unison.
Right.
You shift one, the other will follow.
Sure.
Okay. And at the moment we are adding, you can see at the very end of that chart on the right there, you can see that big uptick in the dotted line.
Yep.
So through most of building human civilization for the last 10 to 15,000 years since the agricultural revolution, concentrations of CO2 in the atmosphere have been at around 280 parts per million.
Right.
In the last 100 years, really, that's pushed up to now over 410 parts per million. That's gone up very, very quickly.
Yeah.
In fact, there's no that pace of change is pretty much unknown throughout this 500 million year history.
Wow.
And you can see that the solid line there is starting to follow. So temperatures are already pushed 1 degree C higher. They will continue to follow that, basically that trajectory of CO2 increases. It's to give you an idea of what's going to happen beyond this. The last time the CO2 was at the levels it is today, if you look back in time, so you can just literally draw a sort of parallel line back through that chart through the years from the top of the end of the dotted line. You'll see you have to go back 3 to 4 million years ago, when temperatures were about 3 to 4 degrees C hotter.
Right.
This point there was no ice in the Arctic, and sea levels, average sea levels around the world were 20 meters higher.
Right.
And remember, at that point, humans were pretty much yet to evolve.
Sure.
So we're already at a pretty staggering concentration of CO2 in the atmosphere, and Earth's temperatures are starting to catch up to that.
I want to interrupt for a second. So you're working as a stockbroker, and what were you like as a kid? What got you going?
So I've always been, I guess, into science. So I always loved science as a kid, and just trying to understand the world and what makes things tick.
Sure.
So I carried that through university, and I did chemistry, and then I went on to do a PhD.
Oh wow!
In UCL, University College London, in materials science.
Oh wow!
So I actually applied for 2 PhDs.
Okay.
Because
you're like an
first one was
underachiever, right?
I try. So the first PhD actually was this was like pure science, like pure kid stuff. And you ask about me as a kid. It was in metamaterials. So
Okay.
these are basically very nano structured, so like
Okay.
billionth of a meter materials, which are structured in a certain way, which can bend light the wrong way.
Okay.
And
Okay.
when you can bend light the wrong way, you can curve light around objects.
Right.
So the idea was to make a Harry Potter cloak or
Right.
a Star Trek cloaking device.
Sure.
Unfortunately, I didn't get that one. Someone picked me to it.
Hmm.
So the second one was looking at basically nanomaterials used to kind of enhance solar panels, so to
Right.
boost the
Right.
efficiency of solar panels by
Okay.
kind of scattering light, so they could collect up more light as it hits them,
Hmm.
or also looking at making windows in buildings essentially mimic the greenhouse effect.
How do
So
you
the
go from
greenhouse effect.
studying this to go into in stock picking? Like that's a bit of a jump. Like what
Yeah, no, it is a jump, and
is it because of
maybe a
the
move to the
math?
dark side.
Is it because of the math? What is it? Why? How did that happen?
So basically, I finished my PhD, and I was thinking about staying on and trying to do a postdoc, eventually a lecturer, but it's very slow.
Yeah.
And once you've done science for 7 years, you realize it's not about eureka moments. It's
No.
about kind of doing an experiment 100 times, and
Yep.
at the end of it, you've figured out 100 ways how not to do something.
Right.
So, and I'm an impatient person. So
No.
I was like,
What?
well,
Wait.
what can I
No. Wait.
do?
Stop. Stop. Sir, I take offense. You are not. No. I will. No. You are not an impatient person, dude. You finished a PhD. That is not. That is a lonely road. That is a hard road. But what I find fascinating is that you're like, I could do the professor thing, the research thing, but shit, I want a nice car, baby. I want a nice house. I'm gonna go into stocks.
Yeah, no, look, that played. My wife works in finance, so she kind of got me interested in it.
Oh, okay,
But I
okay.
was like, hey, I want to carry on this stuff. This is what I'm interested
Yeah,
in.
yeah,
Can
yeah.
it be something more fast paced and more immediate?
Got it.
And so I ended up on the chemicals team at a Credit Suisse, so a
Okay.
global investment
Yep,
bank,
yep, yep.
where I was an equity analyst.
Okay.
So basically, I followed 20, 30 companies, and you forecast, how much cash they're going to make.
Mm-hmm.
You value the stock, and then you go to pension funds and hedge funds and
And
institutional investors,
what's
and you tell
interesting,
them to buy or sell it.
yeah, but in the meantime, in the background, what's simmering in your subconscious is the material science, and obviously the impulse to focus your intellectual energy or attention shifts over to climate science. And so let's go back to your chart then, because I find it, I love it, I love it. So you go, so this particular
Yeah,
graph
so
then,
let me just finish. Let
yeah,
me
yeah,
just
yeah,
finish on that
go
point.
for it, go
So the
for it.
bank, it basically took a couple of years figuring out how the job works,
Yeah,
and I was like, well, I want to get back into what I'm interested in. So I made sure that I was covering all the companies doing new energy stuff.
okay,
So this is what really got me into further into all of this. So
yes, yes,
companies that make materials for batteries for electric cars,
yeah,
or enzymes to make bioethanol
yeah,
for biofuels,
I love it,
or the people making polysilicon for solar panels.
yeah.
And yeah, that became my USP. And I would build these big models integrating all kind of the economics and the science and the technology together,
Oh,
which was
wow,
really the kind of early blueprint for the book.
fantastic. Okay, so when you say you decided to put together this graph, this sort of, okay, let's look at the history, in terms of the correlation or relationship between temperature and CO2 concentrations, and this goes back to 500 million years. This graph truly doesn't exist somewhere?
Yeah, no, yeah. So the I can't remember this one. So this was kind of plotted on separate axes,
Okay.
but it was incredibly difficult to find.
Right.
And all I did is they had collated like hundreds of papers to put this together.
Right.
So now don't get me wrong. This is not an original
Okay.
piece of data work. I'm not
Got
a
it.
climate scientist. I just spent hours and days trawling through the internet trying to find this chart, because
to curate
this to
it.
me is the key chart, right?
to find
I
it.
don't want to see just back 50 years. I don't want to see back 1,000 years.
Yeah.
I want to see through all of time that we can measure and monitor,
Yeah.
whether directly or indirectly. I want to see how temperature and CO2 change,
Right.
because that for me is irrefutable proof
Sure.
that the two follow one another.
Yeah. Yeah.
And like when you combine that with the fact that there is a scientific theory to explain it, that's when you go, hey, you can't deny this stuff. You cannot deny that CO2 increases temperatures. It also works the other way around, by the way.
Right.
If temperatures increase, that also leads to an increase in CO2.
Right. Right.
Or vice versa.
The data don't lie.
The data doesn't lie.
Yeah.
And so stick that in a chart, and then we'll stick on some key moments in human history and Earth
Right.
history, and that gives you a very good appreciation of where we have been for 500 million years, and basically then where we're going to. So that's what's important from this. So we're 8 billion people on this planet now. We're going to rise to over 10 billion people, most probably. And everybody rightfully wants to increase consumption towards the highest standard of living.
Sure.
We're very unequal around the world at the moment. There are lots of emerging countries who rightfully want to bring up the standard of living, which means consuming more energy. And if we don't change the system, that means emitting more CO2. So at the minute, we emit about 50 billion tons a year. That'll grow to about 100 billion tons per year. That little dotted line there will creep up to about 1,000 parts per million by the start of the next century if we don't do something about this.
And for those who can't
plot
see,
that back again, and you have to go back to the dinosaurs, basically.
50 million years ago.
10 degrees C warmer, no ice on Earth. Sea levels were 200 meters higher at that point.
Wow.
And you had 200-pound penguins waddling around New Zealand. And obviously the temperature of the Earth takes time to catch up.
Sure.
To the parts per million CO2. So that doesn't all happen in the next 100 years, but that gives you an idea of where you're headed, very roughly.
Mathew, yes, convincing. Well, it's compelling. Okay. So, is life really a gift? Really? Can you make every second count? That's the whole point of the podcast. So, if you like what you've seen and you're inspired, because that really is my mission, then please give it a like, subscribe, and share.
Shooting it raw?
Yes. Shooting it raw.